Okay, so today we're going to take notes on understanding solutions. And there are several different types of solutions. There's homogeneous solutions and heterogeneous. We're just going to talk about solutions in general and the parts of a solution and the difference between solutions, colloids, and suspensions. So a suspension. A suspension is a solution that has particles in it that can be seen and easily separated. So you can easily pick them out. You can use a filter to get them out. They're a lot easier to see. A good example is pepper and water. You could have muddy water. You can have just rocks in water. Oil in water, where you can see the particles easily, and it's very easy to get them out. In previous knowledge, I like to use the word suspension. In school, a student is suspended if they are seen to do something and we filter them out of school. We say, you know, we can see that what they've done, they're easy to see, they're easy to pick out, and we suspend them from school, or we filter them out from school. A solution is when you have a well-mixed mixture. So as you can see in the picture, you have a liquid, and it obviously has some sort of solution in it that's causing it to turn red. The particles are not big enough to see. You can still see through the solution. It's clear enough. And they don't settle out easily. So this solution will stay this color. The red won't sink down to the bottom. And if you pass it through a filter, the red will just come through the filter. A good example of that is Kool-Aid or salt water, where the salt is mixed in the water, but you can still see through it. Or tea. Tea is a good example. Solution comes in two parts. There is the solvent, which does the dissolving. An example of that is water, and it is present in the largest amount. The way I remember that solvent is what's present. Water is a good example of a solvent, is because I think of the word solvent, and the V is half of a W, and that reminds me of water. And water is known as the universal solvent. We use it to try and dissolve many things because it's polar. It has that electrical attraction to other polar substances. So if something gets dirty, we first try to dissolve it with water. And if that doesn't work, then the substance is probably nonpolar and you need to use soap to break it down better. So the solvent does the dissolving. The second half of the solution is the solute. And the solute is what's being dissolved. Now the solvent is going to be present in the largest quantity, and the solute is going to be present in the smallest quantity. So for instance, if you were talking about salt water, so if I were to have salt water, the salt would be what you have least of in a big glass of water. So you would have the most would be the water. That's your solvent. And the least would be the sugar or the salt. And that would be your solute. A good way to remember that is solute has the U in it, and that reminds me of sugar. And so that helps me to remember that the solute is what's being dissolved, where the solvent is what's doing the dissolving, like the water. So again, water is called the universal solvent because it dissolves so many substances. It universally dissolves. Most, not all. There's a lot of substances water does not get dissolved, but it is a universal solvent. Solutions are in all states. They can be liquid, gas, or solids, and they can come in any combination of the three. A great example of a solution that's a gas, A great example of a solution that's a gas is air. Okay, it's basically the solvent, the thing that's present in the largest quantity is nitrogen. And then what's dissolved in the nitrogen, or what's in the air, what's mixed in the air with it, is oxygen. You've got carbon dioxide, you've got water vapor, you've got argon and other substances that are in our air. Those would be the solutes, and the solvent would be nitrogen because it's what's present in the large quantity. But all of these, except for the water vapor, even the water vapor, are gas states. When you talk about clouds, that's condensed water. So even in our atmosphere, we have liquid water in it as well. So what happens when solutions form? The solute particles are surrounded by the solvent particles. The solute, if you're talking about sugar and water, is polar, and it gets attracted to the polar water particles, and so they electrically attract each other. And so as soon as you pour the sugar in the solution, it gets electrically attracted. So what solutions conduct electricity? Anything that has ionic solutions. And if we go back into our earlier studies of chemistry, we're going to remember that ionic solutions are solutions made with ions like, or ionic bonded substances like table salt, which is sodium chloride. And we remember that the sodium is a metal and the chloride is a nonmetal. And we remember that sodium has 1 valence electron and chlorine has 7 valence electrons, and the magic number is 8. And so the sodium gives its valence electron to chlorine, which makes it an ion because the sodium becomes overall positive and the chlorine becomes overall negative. And so when the valence electron is transferred, not shared, it creates ionic bonds. So a colloid is a solution. So far we've talked about a suspension where, so far we've talked about a suspension where the particles are seen, they're big enough to see, and they're easily filtered out. We've talked about a solution with its two parts, the solvent and solute, where the particles are very small and they're very hard to filter out. So there's your suspension, there's your solution. And the last one we're going to talk about is a colloid. And a colloid is where the particles are large enough to see, but they don't settle out. And a great example of this is a marshmallow or fog. Fog particles in the atmosphere are very easy to see. You could, in fact, they're so large that they block vision. But another really dangerous thing about fog being a colloid is that colloids also scatter light. So when you try and put your high beams on, the light, when it hits the fog when it hits the colloid or the fog particle, gets scattered, and so your beam won't go through the fog very well towards the onto the far side of the road or the other side of the fog, so you can't see the road very well. And so a lot of times they'll tell you, well, it's law that you need to put your low beams on when you have fog. That'd be a good question. I'm assuming it's the law. I know I put my low beams on. We'd have to double check to make sure it's a real law. But you put your low beams on and it helps you see the road in front of you. Where if you have your high beams on, it scatters the light and you can't see on the other side of the fog. Another good examples of colloid are milk. Solutes affect solutions. They can lower the freezing point and they can increase the boiling point. How do we use this in our everyday life? In our everyday life, we say that if we have, we're making pasta. So we have a pot of water and we've got the pasta in there. So what we're going to do is we're going to add salt to the water. And what happens is the salt particles will attach to the water particles, and so when it's time for the water to evaporate, the salt particle holds it in place. And so it's to attach. And water, when it evaporates, leaves all impurities behind. When it evaporates, it comes out as pure H2O without any salt particles attached to it. And so in order for this to happen, the boiling point has to increase. The boiling point has to increase in order for that water molecule to separate from that salt particle and evaporate. Now the same thing happens when ice forms. You have snow falling on the ground. Well, we know that snow is a crystalline solid, and so they like to form crystalline structures and make ice. Well, if we put salt on the ground, then that gets in the way of these ice particles from forming and makes it so that the freezing point has to be lower than 32 degrees Fahrenheit or 0 degrees Celsius in order for this ice to form. So that's why we put salt on the roads in the wintertime when it's snowing, because we don't want the snow to, when it gets below 32, we don't want it to mix together and make, or come together and make ice crystals, and so the salt keeps that from happening. Now, the ice can still form, it just has to be a way lower temperature than 32 degrees Fahrenheit, depending on how much salt you put on the roads. So a review of solution and suspension. A suspension has uneven particles throughout. The particles are larger and easier to see, and they can settle out or be filtered out by filtration. So a great example of this is a suspension is chocolate milk. The chocolate, I know milk is a colloid, but the chocolate in the milk, if you leave chocolate milk to sit on the counter for a long period of time, then the chocolate will settle to the bottom of the glass, and you have to shake it or stir it back up in order to get the chocolate back in the milk, because chocolate milk is a suspension. And a solution has the same properties all throughout. And the particles are smaller, so they don't get, you can see this is a transparent solution. You can see right through it because the particles are so small. And if you were to pour this in a filter, the red would just go right through it. So it passes. They're so small that they pass right through a filter.